All right, so Mia showed you a greedy algorithm to try to solve this traveling salesperson problem that didn't quite work. It didn't find the optimal solution for all graphs. So in this video, we're going to look at a different algorithm that hopefully will work a little better. So by the end of this video, you'll be able to describe a brute force algorithm to solve this traveling salesperson problem. So again, here's our graph. Here's our graph of 8 cities. We want to start and end in San Diego, and we want to find the minimum cost tour that visits each city exactly once and then comes back to San Diego. Here's again our graph represented as this adjacency matrix, where each entry in the matrix is the distance between the city in the row and the city in the column. So what is our approach here? Instead of greedily choosing the next best edge, which could get us into these dead ends that Mia talked about, where you'd be forced to take these really high weight, high cost edges, what we're going to do is we're going to allow our algorithm to just try all possible tours, just try all possible paths through the cities that start and end in San Diego. So that's our approach. It's pretty simple. We'll try them all. We'll just pick the one that's the minimum cost. This is what's known as a brute force solution, because we're not doing anything tricky. We're just going to pound it out. We're going to say, all right, I'm going to tackle this problem basically the hard way. I'm just going to try everything and then pick the best. And it's a very straightforward approach, and a good approach, as we'll see, for some description of good. We'll also see it has its limitations. So let's give you an example of how this brute force solution is going to work. It's pretty straightforward. We're just going to pick one path through the cities from San Diego back to San Diego, calculate its cost by adding up all the distances along those edges, and then say, okay, the cost of this initial path from San Diego to Lima to Paris to Cairo to Perth to Beijing to Johannesburg to Chennai and back to San Diego is 72,211 kilometers. So that is currently our best path. But that's just our first path. So let's try another one. Let's switch the last 2 cities, calculate the cost of that path. Well, that one's only 67,115 kilometers, so that one's better. So we'll record that one as our best path so far. We'll do another switch around some more cities. This is a new path. We'll calculate that cost, which is 70,016 kilometers. That one's not better than the one we had before. So we'll keep the one we had before as our best so far. And so on and so forth. So we're just going to generate all of the different paths that exist, keep track of the best one at each point, and at the end of the day, once we've considered all the paths, we'll have the best. And so this works. It's going to find us the best path. And in this case, I implemented a solution for this problem, this brute force solution, and I found that the best path is actually to go from San Diego to Lima to Paris to Cairo to Johannesburg to Perth to Chennai to Beijing and then back to San Diego. And that has a total path cost of 55,242 kilometers. All right, so this works. Great. But the problem is, how long is it going to take? You might be thinking, I don't know. There seems to be a lot of possible paths we could take between these cities. Is this really a feasible solution? And if you have that concern, you'd be right. So in the next video, we're going to consider the running time of this solution, as well as the greedy solution that Mia presented.